13 on 364. And you said y equals the square root of x. They're asking us to find dx over dt when y equals 4 and dy over dt equals 1.75. Okay, perfect example. So what is this telling us? This is a function of time, or t. T doesn't have to be time. I just named it time, but y is a function of t. X is another function of t. Exactly like in my silly example with the balloon. Good. So we don't look at this information yet. Those numbers are not telling us anything. We want to differentiate both sides, keeping in mind that this is a function and this is a function. They're both functions of t. So what do I write on the left-hand side when I differentiate y with respect to t? Give it a try, please. Anyone?
Would it be 1?
It's a function of t. That's why I put a little dot underneath. In other words, it cannot be treated as a variable.
dy over dt.
That's it. This becomes dy over dt. Awesome. Now remember, this is the square root of a function prime. Perfect. The left-hand side is done. Let's think about the right-hand side. And please remember the formula. The square root of a function prime. Can anyone help with this one?
It's 1 over 2 square root of f.
dx times dx.
Careful. This is a derivative, it's not a differential. And this is a function, it's not a variable.
Is it times 1? No.
It's a function.
The square root of f.
Okay, I'll come back to this. So when we differentiate, let's review this because this is important. When we differentiate a function to the third power, what do we write?
It's 3f squared times 3.
The inner function prime.
The inner function prime. Thank you so much. Please remember, times the inner, write it on a piece of paper and tape it to your computer, times the inner function prime. Please do not ever forget this. If this is plain x, then you are correct to stop here because x prime will be 1. But if this is a function, we can never stop. We have to say always, in the back of your mind, you have to have this sentence somewhere, times the inner function prime. Okay, now let's analyze this. Anyone?
It's 1 over 2 square root of f, and then is it going to be times square root of f again?
Times the inner function prime.
F prime.
Times f prime. So please have these formulas handy because they are really the bread and butter, right, of what we study here. Times the inner function prime. Times the inner function prime. Good. So we have the left-hand side. Can anyone help us with the right-hand side?
1 over 2 square root of x times x prime
Good. But I have to write it like this.
times dx over dt.
Very good. Awesome. So now they're asking us to find this given that y is 4, dy over dt is 1.75. That was very interesting. Is that a particular chant or a particular song that we should know about?
No, it's Ramadan time. It's like iftar time for me.
Very good.
So I'm, like, about
That's
to
what I
break my
thought.
fast.
Very good. Interesting. It was interesting. Thank you. Good. So in order to determine this, we have to plug in. One option would be that's a plug in, replace dy over dt by 1.75. And we're given y, we're not given x, but that's no problem. If I'm given y as 4, 4 equals the square of x. Can anyone give us x? So we have it because, or you can just replace the square of x. We don't need to find x. The square of x is 4. So this piece is 4. This piece is 1.75. And they're asking us to find dx over dt. So let's write the equation one more time. So 1.75 equals 1 over 2 times 4 times dx over dt. And we are after dx over dt. So we multiply both sides by 8. So then dx over dt equals 1.75 times 8. How much is this? That's 4, 56, 0, and 6, and I think it's 14. Correct me if I'm wrong. Is dx over dt 14? If it is, fine. If not, please correct me. Any questions on how we determined dx over dt? We'll choose other problems in a minute. But are the steps clear?
Yeah, I just have a question.
Yes. Yes.
So you put it says y equals 4, so then why did you put 4 into x?
No, I put, no, not into x, into the square root of x. So
Okay.
if y is 4, it means that the square root of x is 4. So I replaced all this by 4.
Oh, okay, I got it. Thank you.
Better?
Yes.
Perfect. So let's choose other problems. If you want to stay with the same, in the same column, if not, we move on to the next column.
Can we do number 2?
Yes, let's do number 2. This one here? Yes?
Yeah.
Perfect, number 2. We have y equals x to the 4th, and they ask us to find dy over dt this time. Given that x equals 3 and dx over dt equals 1.5. Based on the given information, we know that y cannot be treated as a variable, but as a function of t. Based on the given information, we know that x cannot be treated as a variable, but as a function of t. How do we proceed? Anyone would like to explain or guide us?
You first have to find like the derivatives.
Yes. Yes. So we want to start with the left-hand side. Don't look at the right-hand side. The left-hand side.
It's just dy over dt.
Excellent. Now we are looking at the right-hand side. Knowing that this is a function. This is a function to power 4. Ready.
4x over
Power.
to the 3rd
Yes.
times the inner function prime.
Awesome. What should I write for the inner function prime?
Is it 1 over,
It's not a square root.
okay, dx over dt.
That's it. That's it. So we're asked to find this, which is this, knowing that x equals 3. So this will be replaced by 3 to the third, and this will be replaced by 1.5. So dy over dt will be 4 times 27 times 1.5. So 4 times 27 times 1.5, 162. Good. We're feeling better a little bit?
Yes.
Okay, let's choose, where am I? Okay. Let's choose one more from here and move on to a word problem. And that's the end of chapter 3. Just applications of differentiation. Can I choose 17?
Yes.
Okay, so 17. In 17 we have y equals p squared times q. Find dq over dt, knowing that p equals 15, q equals 40, dp over dt equals 55, and dy over dt equals 54750. Let me see if I copied from one problem, because as you know, my computer is so far away. Okay, p, yes, that's correct. Q 40, yes, that's 55. dp over dt, yes. Okay, perfect. So obviously this is slightly more complicated, because now, based on this and this and this, what do I conclude about this equation? What will you say to yourselves? Oh, this equation has what? What does this equation have according to this?
It has like 3 differentials.
3 functions of t. Yes, 3 functions of t. Good, awesome. Once we notice that, I'm going to put a little dot so we know that these are functions. So we don't forget. We cannot treat them as variables. They are functions. Good, so then we differentiate. Now careful, because this is a product of 2 functions. So let's differentiate the left.
Is it dy over dt?
That's it. That's a nice one, easy. Now careful, function 1, function 2. Let's try. It's okay if you're wrong. Once you're wrong, then I know what to address and what to do and what to say.
Would the first one be 2p times dp dt?
Awesome. Times the second function q, now plus. Awesome. Of course, I'm going to crash with this, so I'm going to write it underneath. You don't have to, but I don't want to go over that. Plus.
P squared
Yes.
Q dt, oh, like dt over dt.
Awesome, brilliant. That's it. Yay. Well done. Okay, so now, what am I after? This is what I'm after, because that's the question. So I'm going to plug in everything. I could solve first and then plug in, or I can plug in and then solve. It doesn't matter. Do I have this? Yes. 54750. 2. Do I have p? Yes. 40.
In the question, was it 7,500 for dy over dt?
I copied from something else?
I don't know. I
I'm
might
a
have
master. I'm a master of that.
Oh, I copied from something else. Okay, never mind.
Yay! It's not
Sorry.
me this. It's not me this time. One time. It's not me. Thank you. You made my day. So 2 is 2. P is 40. dp over dt, 55. Q. What did I do? Ah, see? I did it. It was 15. So, one more time. 2. P, 15. dp over dt, 55. Q, 40. Plus P again, 15, but squared, times the unknown, dq over dt. So, I'm going to have this minus all this and divide by 15 squared to get this. So I move this to the other side and then divide by 15 squared. And that's it. As I said, the second half is always just algebra. So dq over dt, 15 squared in the denominator, 54750 minus 30 times 55 times 40. I'm going to share my screen and do this in one step, please. Left parenthesis. I don't understand why this appears all the time. So 54750 minus 30 times 55 times 40, close, divide, 15 squared. I'm checking. 54750 minus 30 times 55 times 40. Yes, okay, okay. Negative 50. So dq over dt is negative 50. Well done.